Salam, peace be upon you. My name is Muhammad Layak Siddiqui, the father of Holophase. The Story of Change, Part 19. What is coarse graining? Where we are. Let us take a slow breath and remember where we are. We have been building something careful. We started with a cup. The cup was whole. Then the cup was broken. Everyone saw it happen. But we refused to say, time passed, so it changed. That felt too easy, too magical, too hard for strangers to check. Instead, we built folders called state packages. Each folder holds a snapshot of something at one moment. What we looked at, how we looked, what we are allowed to claim, how uncertain we honestly are, and the trail so anyone can repeat our looking. Then we built receipts called update certificates. These receipts prove that one folder legally leads to another folder. They pass through 8 gates, like 8 checkpoints. If a receipt fails a gate, we do not accept it. We write a refusal certificate instead and put it in a special drawer called the negative archive, so we remember what did not work. Then we built an immune system. If we discover an old receipt was wrong, we revoke it, and we revoke everything that depended on it. We call this a revocation dossier. Then we built a graph. Dots are folders, lines are receipts. The whole drawing is called graph G sub U. We said, a universe is not a place, it is a connected record. Then we built order, not from clocks, from chains. We said, S1 comes before S2 if you can walk from the first folder to the second folder by stepping along receipt lines. Then we built propagation limits. We said a change can only spread along paths that have legal receipts with open gates. No distance, no speed, only connectivity and permission. Then we built transformers. We said a law is not an equation on paper. A law is a registered machine that turns one folder into another. Every transformer lives in a public registry with its full declaration. Then we built composition. We said we can put transformers together in a chain, but only if the types match and all gates still pass. Then we built conservation. We said a quantity is conserved under a family of transformers if every valid receipt in that family shows it stays the same within uncertainty. Then we built interaction. We said two things interact when you cannot split the change into separate receipts for each thing. Interaction is certified non-factorization. Then we built equations. We said equations are not assumed. They are what remains after all illegal updates are refused. Equations are survival conditions. Then we built branching. We said multiple possible next steps appear when ceilings are low and uncertainty is high. The branch set is all the folders that could legally come next. Then we built probability. We said probability is not magic. It is a certified assignment rule over the branch set based on evidence with normalization and invariance tests. Now we have many folders, many receipts, many transformers, many families, many patterns. And we have learned to be honest about what we know and what we do not know. And now we face a new question, a question about looking at the same thing in different ways. How do we move from a detailed view to a simpler view without losing honesty? The opening scene, the forest from above and below. Imagine you are standing in a forest. You look around. You see individual trees, oak, pine, birch. You see their leaves, their bark, their branches. You see the moss on the ground. You hear birds in the canopy. That is a detailed view. Now imagine you climb a tall tower above the forest. From up high, you cannot see individual trees anymore. You see a blanket of green. You see the shape of the forest as a whole. You see where it meets the fields. You see patches of lighter and darker green. That is a coarse view. Both views are real, both are honest, but they are not the same. The coarse view has less information. It has thrown away details. It has kept only what matters at that scale. In our world, we call this coarse graining. It is moving from a detailed folder to a simpler folder by declaring what we keep and what we discard. But here is the key. Coarse graining is not magic. It is not vague. It is a declared information discard. The big idea here is what we discover. Macro is not a different universe. Macro is a declared information discard. Coarse graining is legal only through registered interfaces that declare what is preserved and what is discarded. You cannot just say, let's look at the big picture. You must say, what information am I keeping? What information am I throwing away? How does my uncertainty change when I throw it away? How does my ceiling change? How much detail can I now see? Without these, coarse graining is not honest. It is just blurring things and pretending nothing changed. What does that mean? Let us unpack it. We have a detailed folder. It contains many things: positions of every tree, types of every leaf, sounds of every bird. We want a simpler folder, one that just says, forest, mostly green, about 100 years old. To get there, we must have a coarse grain interface, a registered rule that says, domain mapping, from the detailed domain, each tree, to the coarse domain, the whole forest. Invariance preserved, things that stay the same, like total forest area. Information discarded, a list, exact tree positions, leaf colors, bird songs. Uncertainty change. When we discard information, uncertainty usually grows. We must say how much. Ceiling change. The coarse folder has a lower ceiling. It cannot see the fine details anymore. We must declare that. This interface is public. Anyone can look at it. Anyone can check if it was applied correctly. The map example. Imagine you have a map of a city. It shows every street, every alley, every building, every tree. That is a detailed folder. Now you want a simpler map, one that just shows the main roads and neighborhoods. You do not just blur the detailed map. You create a new map with the declared rule. Preserved: main roads, neighborhood boundaries, river. Discarded: side streets, building shapes, tree locations. Uncertainty: positions on this map are accurate to within 100 meters, not 1 meter. Ceiling: you cannot see individual buildings anymore. That is a coarse grain interface. It is honest about what was lost. If someone looks at a simple map and asks, where is the bakery on Maple Street? You cannot answer. That information was discarded. That is honest. The important turn. Now we say something that sounds strange at first, but becomes obvious. Coarse graining is not about the world being fuzzy. It is about us choosing to ignore details for a purpose. The detailed world is still there. The coarse folder is not a different world. It is the same world, seen through a filter that removes information. And that filter must be declared. If you do not declare what you threw away, you are not coarse graining. You are hallucinating. The photograph example. Imagine taking a photograph of a crowd. The detailed version is a high-resolution image. You can see each person's face. Now you reduce the resolution. You make it blurry. Now you can only see shapes and colors. That is coarse graining. You discarded the fine details. But if someone asks, what was that person wearing? You cannot answer. The information is gone. If you had kept a list of what you discarded, individual faces removed, clothing details removed, only crowd density preserved, that would be honest. Without that list, you might forget you threw anything away. You might think the blurry image still contains the faces somehow. That is a mistake. The coarse grain interface registry. Now we build something new, the coarse grain interface registry. Every time we want to move from a detailed folder to a simpler folder, we must use a registered interface. That interface has an ID. It declares domain mapping. How do we go from the detailed domain D1 to the coarse domain D2? For example, from each tree to forest as whole. Invariance preserved. What stays exactly the same? Maybe total area, maybe total number of trees, maybe total biomass. These must not change in the coarse version. Information discarded. A list of what is thrown away. Exact positions, individual colors, small variations. This list must be explicit, not some details, specific details. Uncertainty transformation. When we discard information, uncertainty usually grows. The coarse folder must have larger uncertainty bounds. The interface says how much larger. Ceiling change. The coarse folder has a lower ceiling. It cannot see the fine details anymore. The interface declares the new ceiling N-max2. Anyone can look up an interface. Anyone can check if it was applied correctly. If you use an interface without declaring these things, your claim is refused. The water glass example. Imagine a glass of water. A detailed folder might contain the position of every water molecule, their speeds, their vibrations. Now you want a coarse folder, one that just says temperature 20 degrees, volume 250 milliliters. You need an interface. It declares domain mapping from molecules to bulk properties. Preserved, total mass, total energy. Discarded, individual molecule positions, their exact speeds. Uncertainty, temperature is accurate to within 0.5 degrees. Ceiling, you cannot see individual molecules anymore. That is honest coarse graining. You know what you kept and what you lost. If later someone asks, which molecule was at the bottom? You cannot answer. That information was discarded. That is honest. The two kinds of coarse graining. Now we discover something important. There are two ways coarse graining can happen. First, throwing away detail you once had. This is like the high-resolution photo becoming blurry. You had a detail, then you chose to discard it. The interface records what was lost. Second, never having the detail at all. This is like the weather forecast. You never had every air molecule's position. You always worked with coarse variables like temperature and pressure. The interface here declares what you are not even trying to track. Both are legal. Both require interfaces. Both must be honest about what is present and what is absent. The weather forecast example. Imagine a weather forecast. It predicts temperature, wind, rain chance. It does not predict the path of every dust particle. That is coarse graining by never having the detail. The interface declares domain mapping from atmosphere to grid cells. Preserved, average temperature, average pressure, total rainfall. Discarded. Exact positions of every molecule, turbulence at small scales. Uncertainty. Temperature accurate to within 2 degrees. Ceiling. Cannot see details smaller than 1 kilometer. That is honest. The forecast does not pretend to know what it does not know. The stress test. Renaming again. Now we do our stress test again, because it protects against cheating. Suppose we rename everything. Phi goes to phi plus c. Do coarse-grained interfaces survive? They must. If we rename all the trees, the coarse interface should still produce the same coarse folder. The forest shape should not change just because tree names changed. If the coarse folder changes under renaming, then the interface was depending on labels, not on real structure. That is not allowed. Gate 4 catches this. The predictions. Now we make predictions, not prophecies. Predictions like receipts, things we can check. Prediction 1. Any coarse-grained folder must come from a registered interface. No interface, no coarse graining. Prediction 2. The interface must declare what information is discarded. Vague statements like some details ignored are not enough. Prediction 3. Uncertainty grows, or at least does not shrink, under coarse graining. If uncertainty magically decreases, something is wrong. Prediction 4. Ceilings go down, or stay the same, under coarse graining. You cannot see more detail in the coarse version than in the detailed version. Prediction 5. Coarse graining survives the rename everything test. If it fails, it is invalid. These are simple. They can be tested, they can be audited. The failure signatures. Now we list the ways coarse graining claims can fail. Each failure produces a refusal certificate that goes into the negative archive. Failure 1. No interface. Someone presents a coarse folder but does not cite a registered interface. Refused. Failure 2. Vague discard list. The interface says some details ignored, but does not list them. Refused. Failure 3. Uncertainty shrinkage. The coarse folder has smaller uncertainty than the detailed folder, with no justification. Refused. Failure 4. Ceiling increase. The coarse folder claims to see more detail than the detailed folder. Impossible. Refused. Failure 5. Invariance failure. The coarse folder changes under renaming. Gate 4 catches this. Failure 6. Domain mismatch. The coarse folder's domain does not match what the interface declared. Failure 7. Preserved invariance broken. Something that was supposed to stay the same changed. The interface was misapplied. Failure 8. Replay failure. Another team cannot reproduce the coarse folder from the detailed folder using the declared interface. Failure 9. Hidden assumptions. The interface depends on something not declared, like a specific way of averaging. The bakery example. Imagine a bakery. A detailed folder might contain every loaf of bread, its weight, its baking time, its position on the shelf. Now you want a coarse folder, one that just says total loaves 47, total flour used 23 kilograms. You need an interface. It declares domain mapping from individual loaves to totals. Preserved total count, total flour mass. Discarded each loaf's exact weight, baking time, position. Uncertainty total flour accurate to within 0.1 kilograms. Ceiling cannot see individual loaves anymore. That is honest. If later someone asks, which loaf was baked first? You cannot answer. That information was discarded. The river example. Imagine a river. A detailed folder might contain every water molecule's position and speed. A coarse folder might contain flow rate, temperature, turbidity. The interface declares preserved, total water volume, average temperature. Discarded, individual molecule paths, small eddies. Uncertainty, flow rate accurate to within 5%. Ceiling, cannot see details smaller than 1 meter. That is honest. The course folder is useful for some purposes, but it cannot answer questions about individual molecules. The main lesson. Let us say it one more time, in the simplest words we can find. Macro is not a different universe. Macro is a declared information discard. If you want to talk about the big picture, you must say what you are throwing away. You must say what you are keeping. You must say how your uncertainty changes. You must say what detail you can no longer see. Without that, you are not coarse graining. You are just blurring things and pretending nothing changed. What coarse graining is not. Now we say what coarse graining is not. Coarse graining is not a different reality. The detailed world is still there. The coarse view is just a view. Coarse graining is not a loss of accuracy. It is a trade. You lose detail, but you gain simplicity. Coarse graining is not permanent. You can always go back to the detailed folder if you kept it. The coarse folder does not replace it. Coarse graining is not free. It requires an interface. It requires honesty about what was lost. The forest at the end. Remember the forest? From the ground, you saw every tree. From the tower, you saw only the green blanket. Both views are real. Both are honest. But the tower view cannot tell you about the oak's acorns. That information was discarded. That is coarse graining. Not magic, not fuzziness. Just choosing to look at the whole instead of the parts. And being honest about what you lose when you do. The interface declaration. Now we have something new in our notebook. Interface declarations. For each coarse grain interface, we record the interface ID and version, the domain mapping, the list of preserved invariants, the list of discarded information, the uncertainty transformation rule, the new ceiling, test results showing it works, the date of registration. These declarations are public. Anyone can check them. Anyone can challenge them with counterexamples. The preservation and loss reports. We also keep preservation and loss reports. These show, for each use of an interface, which detail folder was the source, which coarse folder was produced, what was preserved, and proof that it stayed the same, what was discarded, and evidence that it is gone, the uncertainty bounds before and after, the ceiling before and after. These reports are linked to the update certificates that perform the coarse graining. The honest scientist. Imagine a scientist studying the forest. She has detailed measurements of every tree. She wants to publish a simple result. The forest is healthy. She does not just say that. She declares her interface. Preserved. Total biomass, species diversity index. Discarded. Exact positions of each tree. Which birds were singing? Uncertainty. Biomass accurate to within 5%. Ceiling. Cannot see individual trees in this result. Then she publishes. Anyone can check her work. Anyone can see what she kept and what she threw away. That is science. That is honesty. What comes next? Now we have coarse graining. We have a way to move from detailed views to simpler views, honestly. We have interfaces, registries, and reports. Next, we will ask, how do coarse-grained views connect to each other? How do we know when a coarse-grained description is good enough? How do we handle situations where different coarse grainings conflict? Those are for later parts. For now, we rest here. We have coarse graining as declared information discard. Not magic, not fuzziness, just honest simplification. And we built it all from one simple idea. Macro is not a different universe. Macro is a declared information discard. That is part 19. That is what coarse graining is. That is our story so far. Always, peace be upon you.